It should ding. I'll do. All right. Um, so welcome, Joel. How do you say your last name?
Meador?
Meador. Thanks for doing our monthly speaker event for this month of July. We will be posting this on YouTube, so those who watch it later, you can feel free to leave comments or any questions if you have any. And yeah, I'll let you just get right into it. If you want to spend a little bit of time talking about who you are and what you're doing in your day job, and then dive into it, be great.
Cool. I'll cover that in one of the slides, actually, so we'll get into it. All right, I'm going to do a talk about code reviews and how to do that with empathy and effectiveness. My name is Joel Meador. I want to talk a little about my experience, my work at SmartLogic. So my name is Joel Meador. My pronouns are he, him. I live on Miami and Kickapoo land, and in my free time, I have a kid, and I like to garden and go into forests. Professionally, I've been working for about 20 years, 20 plus years at this point. I've been doing process and development consulting for about 15 of those years. I was exclusively a code review consultant for multiple years. And I worked as a release manager for a few years as well. I've been at SmartLogic for about a year. There I have been in developer role, individual contributor role. I'm also currently an acting EM, engineering manager. I was having trouble with the acronym. Engineering manager now, and technical lead. And a little bit about SmartLogic. We're a custom web and mobile application development shop, and we build custom software, usually from the ground up, and we're funded startups and established organizations. Really anyone who needs like technical assistance or a technical team and don't have the internal folks to do it, or don't have bandwidth inside of their technical teams inside, or need some sort of specialized help. And we mostly work on Elixir and native mobile and Rails apps. And I've been doing Rails for I've been mainly doing Rails for like 13, 14 years. I don't know, a while. So first things first, when it comes to code review, what is it? What outcomes should we have? Why is it important? So ideally, the outcomes of a code review are that we change some system that we're managing or developing, and we do it without taking the rest of the system offline. And we do it in the way that was expected based on everyone who's involved, all the stakeholders, all the owners, product owners, developers, everyone gets what they expect. And at the end of that, once a code review is done and a change request is put into the system, everyone who needs to know learns about the important system changes that occurred. Some non-ideal things that can happen after a code review if it doesn't catch the things it needs to. You may bypass a code chain of ownership, responsibility chain, and someone might get mad. Something may go wrong in hardware, software changes where you have to invoke emergency procedures, up to and including, disaster recovery. Bad things that can happen interpersonally. You may exacerbate or create team dysfunction because of code review. And ultimately, like any of these things, if you do enough times and have bad outcomes, people will quit over code reviews. And certainly they can become very unhappy about it. So I want to go through a list of things I think are good to do, some techniques and some things to look out for, and I've got some examples and things. But I think a really key thing that I want to start with is it's very easy to give negative feedback, and I think it's important to give positive feedback during code review as well. And I think what we want to do mostly is show people that we respect them. When we're doing code reviews, particularly for in technical leadership of some kind, there's often an inexperience of power sometimes, and an experience between us and the person we're reviewing. So we should always keep that in mind when we say things to people, because if we're not nice to people, that can have very serious ramifications on people's careers. So a way that we can do that and enforce that we like things is giving people recognition that they did good things. So don't skip over the things you like, and that might mean, I like the way you wrote this test, it's very clear, or leave a little smiley emoji, or just say yes, exclamation, if you see something you like. Another part of that is sharing things with your team, or your boss, or your group, your engineering group, whatever you think is appropriate to share good things. So if you're sharing with the team, it might like, hey, did you see this cool thing that this person did with this code? It's neat. Or did you see this cool change they made to the hardware? It's so cool. I think it's important to do this because, one, it's very easy and it doesn't take very long. Two, it reinforces that, we're recognizing that people are doing good work, because it's very easy to get lost in a large pull request or a small pull request and be very negative and make people feel bad. I've certainly suffered from that, and at times, both on both sides of it, and have hopefully learned my lesson for the most part to not do that. I think the last thing to show people you respect them is to respond quickly when someone asks you your opinion about some code, when they ask you to do a code review for them. It doesn't feel good to be ignored. So we can do code review quickly, or we can offer people a schedule, or just say, no, we can't do it. An update that's respectful and helpful to people is, I couldn't get to this as I expected. It's my top priority in the morning. I'll have a review by 9 a.m. your time or whatever. So that's an easy thing to tell people. And it just shows you that you respect their time and their attention. So now that I said let's be nice first, let's talk about some issues. So these are going to be kind of most specific to or I guess most micro level to most macro level, and kind of the things that we'll look for roughly. So the easy stuff, a lot of this stuff is stuff that could be fixed by a computer to some extent, like a formatter. So the easiest thing is formatting. For writing Ruby, we have Rubocop and other linters over in Elixir or JavaScript or whatever. There's ESLint and mixed format, Credo, etc. So it doesn't really matter. It does matter, but it's not as important that we choose some particular style. It's just that we all understand how that's going to be enforced, or if it's going to be enforced, and what the side effects are of that. So that could be spacing versus tabs, or how we write our constants, or how we space our hashes, whatever the thing is. Another thing to look out for is naming conventions that go against the project norms, and non-revealing ones in particular. So you could write user 1, user 2 in a test, but it might be better to write user who cannot log in and user from different company. Those are both like examples of like a user that reveals what it's up to in a test or in your application code. Another example of non-revealing code might be if you're doing a code review, and when we're doing code reviews, often we don't always pull up the code on our machine. Sometimes we're just evaluating in our head. And kind of the rule of 7 plus or minus 3 is, if I can't figure out what's going on in my head while I'm reviewing, it probably means that there's too much indirection, right? Sometimes you'll get into a code review and there's 15 layers of indirection. You're like, I don't know what this is doing anymore, because I've had to go through 5 files and I don't know what's happening. So I think that's something to be on the lookout for when you're code reviewing, is like, you've made this too complicated, or the system is too complicated, whatever the answer is. So I made up a stat you spend 90% of your time reading old code, so it makes it easy to figure out what's going on, or sorry, make it easy to figure out what's going on when it's new, because in a year you're going to have to maintain it, or someone else is going to have to maintain it, and if it's not easy to follow, they're not going to have any of the context, so it's going to be all new to them, and they're going to have to recreate exactly what you did, but you may have new commits on top of that, so figuring out where it came from is going to be much tougher. So make it easy on yourself, make it easy on the code reviewer. If you're having trouble evaluating something, that's often, as you're code reviewing, like that's something to say. Like, I'm having trouble understanding this. Can we write this in a different way? So the next level up maybe of things is structural issues that we can find in code or in an application. So in Rails, the convention is we have some file in the models directory, and it's named post users or something, or post user. And so we expect a class named post user to exist if that file is there, but it might be called fish user or something. And we know that's a smell. We can figure that one out, because if it works in development, it may not work in production because of the way that loading works. So that's something you can see, and that's another one maybe we can find if we'll enter, but it may not come up. Another thing, as you do more code review, particularly in technical leadership, you'll start to find these issues that come up over and over again. So are you finding design issues in the system that you've previously noted as part of this code review? Does that mean it's now time to deal with those, or should we put it off again? Like, these are the decisions you have to make when you're code reviewing. Another one to think about is if you're seeing a new design decision or something that's exacerbating one and making it worse or harder to understand, or whatever way you want to describe it. What do we do about that? We should strive not to make our applications more complicated, harder to understand, harder to maintain. Another thing to look out for is abstraction levels. I haven't thought of a good way to explain this other than the amount to which you are applying the law of Meador, which is, you're only ever calling one method off of an object, never more. So as long as your level of abstraction in that sense is consistent, and you're not doing like different kinds of things with different levels, you're usually good. A lot of times that just means you're writing little functions to call little methods, particularly if you're doing like some hash mapping and then calling functions off that data and then doing more hash mapping. If you're all doing that in the same place, like maybe you can move some stuff around and make it easier to follow and make a story instead of blobs of code. I think the last thing to look out for structurally is, are there things that are coming to light as part of this review that need to rise to the level of everyone in the project finding out about it, or everyone in your engineering group, or potentially everyone in the company management. So that could be a variety of things, like this is going to bankrupt us if we deploy this, for example, is one where you want to bring that up. How do we deal with this as an engineering group? Did you have a question, Sean? I thought you turned on your video.
No, you're good, man.
Okay, cool. Next thing to look for when you're doing code review, performance issues. This first one is, are we doing 150 queries when we can do one? That's sort of an N+1 thing. Very well-known problem that occurs sometimes. Active Record makes it really easy to hang yourself with N+1s. This is the kind of thing where you're creating a lot of application load where your SQL Server or whatever you're using could do it easily, very quickly without that. Another one to think about is something that I see in this code that's changing, going to like bring my app server offline, going to eat all the RAM or eat all the CPU. If you have some tight inner loop, for example, that's creating symbols based on user input or just based on the request number, like that will eat all your RAM, particularly if you're putting a lot of requests through. And it can happen pretty quickly. Or if you have a lot of requests and you're recording each one, you can exhaust a database ID generator, for example, particularly if you're in a 32-bit ID kind of situation. It doesn't take long to run out of those in high volume systems. So those are kind of things you can do to eat your system up. Another point to look for is data or code complexity versus locality of data. Sometimes it's much easier to make a lot of calls that are kind of dumb and not performant, but it doesn't necessarily mean the application is going to be able to handle that. So sometimes it makes sense to make our code slightly more complicated so that caching happens. So that could be anything from like memoization locally, all the way up to, we lost the presenter. We lost the person that was recording. I guess it's still happening. So that could be memoization all the way up to in-process caching, all the way up to Redis as a cache or memcached, and so on, so on. So are we making a good trade-off? Another thing to think about is, are we using the wrong methods, wrong libraries, wrong data structures when we're doing kind of looking at data and responding to requests and things. So if we're trying to find something in a list, are we using a big O order in thing to look through every item in the list? Are we using binary search so we only look through O login? So these are the kind of things that we want to think about. That's a bad example because most libraries handle that for you, but sometimes it happens. Then the last thing that I think is important, and this is certainly not an exhaustive list, but a thing to look out for is, will the changes that we're reviewing deal well with production data? So for some systems that might mean, will this deal with 1,000 rows? Some systems it might mean, will it deal with 1 trillion rows? And we don't know if we can't recreate that in some way and test it. And another thing to think about is if you're adding things to the database or whatever system there, is that system going to be able to handle that new load that we're creating? So, indices take time and RAM and CPU to make. So even if we're solving the problem that this will work with 1 million or 1 billion rows, are we creating other problems, and can we deal with those? All right, so that's kind of a short performance piece. Next, we'll talk about security. So there's a lot of things in security. This is also not exhaustive. None of these are exhaustive. It's just things that I think are important to look at. Is authentication and authorization rights. This is kind of a thing like authentication go both ways. You could be too secure or not secure enough. For example, don't put your marketing pages behind a login, because then no one can see your login pages or see your marketing pages. But also don't put private PII, don't put private personally identifying information out into the public internet. Those are both bad in different ways. Is authorization right? Like if you had an administrative console in your application, normal users shouldn't be able to get to that through any means. Another thing to look out for, which doesn't happen all the time, but it is possible still to write this in Rails and other systems, like are we allowing raw user input to come into the system, either being displayed on a web page or being put into the database directly. The latter is a lot harder, particularly a factory record or something like Ecto or whatever, but it can happen. And it seems like it happens a lot more when you're rendering things that the user is input, that they're doing something unsafe or easy to hijack a session. So, you have to look out for these things. This is called SQL injection. If you want to look up this thing, that's what it is. So are we using out-of-date libraries? Security practices. So out-of-date security practices might be like you're not having you don't have a secure server as a perfect example. That's almost impossible these days, but it is a thing that some people still do. You're not using a VPN to do deploys, or you don't have strong SSH keys. Like there's a number of things that are kind of just bad security problems that are easy to solve. So what is this change to the system doing that's making our security system better or worse? Another thing to think about is, did the application boundary change? And how do we deal with that? So that could be anything from like we added new endpoints to an API, or we changed how our role system works, like a user role system works, or we added the ability for users to delete things that they couldn't delete before, and there's some consequence that we didn't think about, like where unauthenticated users might be able to see something. These are all things where when we change a system, if we don't have good rules and good code review around, like it's easy to get into a situation where like something bad will happen and someone's data will be exposed, or someone will mess up valid data and make the system unusable because there's no good data left in it, these things. So these are all kind of security things to think about. It's a big problem to crack, and you'll mess up sometimes, and that's what code review is for, to stop you from just pushing your mess up into a production system or into a user-facing system. So your code reviewer is there to help you out. So I've covered a bunch of things that I think are fairly universally good to do and to look at. And I just want to talk for a minute about my personal style and how I like to review, like things I like to do that might not necessarily work for you. I think this is certainly something that might be universally good for technical leaders. I'm not sure, but I like to make observations with the person who is changing the system about medium long-term issues we're seeing, because part of my job is like training future senior developers, basically, or future technical leaders. So if they don't know what the medium, short, long-term implications or ramifications of what they're doing are, like they can't grow into that role ever, or it'll be much harder for them. So examples could be like data growth and retention. If you add, for example, an auditing system or an auditing tool to your system, that often involves lots of data being recorded at all the times. And there are data retention policies that have to be thought about, and like when is my server going to fall over because I've got too much audit data, etc. Things that you might think about are logging strategies. How easy is it to debug issues that occur in the production staging environments? Things that are good to think about, or just generally like how much threshold do we have, or sorry, how close to the threshold are we with our current systems from like running out of resources at peak? And how does this change interact with that? Does it make it worse or better or the same? And generally, most things are neutral, right? Most things are not pushing you significantly toward going over a threshold and your system falling apart. But it's a million paper cuts kind of situation. So anyway, I talk about these things and make comments to people, either on their code or in person or however is best in the context, so that they know about these things. So what's going to happen in the future? How are we going to deal with this? What are some of my ideas about dealing with this? Eventually we'll choose one, or the problem's gone, or whatever. The system changes enough that we don't need to think about it anymore. But this is like long-term thinking. How do we grow a system that changes over years, months and years, particularly with lots of developers looking at it? Another thing that I like to look at when doing code review is obsolescence. And I think this is one that gets overlooked a lot. When we're changing a system, a lot of times we're paying attention to what's around the changes, or we should be, because sometimes the code that's around things hasn't been used in a decade or something, and we can remove it. And the more detritus we remove from the system, like the easier our time will be in the future maintaining a system. So that could be methods that are unused. That could be modules that are used. That could be classes, that could be database tables, that could be gems in the Rails context that we're just not using anymore because they've been replaced with framework features. So there's a bunch of stuff where obsolescence happens over time for various reasons, and we should be aware of that and like push to make our system simpler, and preferably having fewer dependencies over time. But certainly we can simplify code when we see it and remove things, and the less we have, the less we have to maintain, which is nice. So I think a good example of this was Active Job, which came out, I don't know, like 6 years now ago. But Active Job vastly simplified a lot of things that happen in the Rails world, and made it so that we didn't have to basically make Active Job over and over again in our systems. One more thing I want to talk about is balancing velocity and thoroughness. I think this is a good thing to think about when we're doing code reviews. So I said earlier, we should be fast and respectful of people's times, but we also have to do a good job. And the reason we want to do a good job is because as a reviewer and deployer and technical lead, I'm often on the hook if something goes bad. And the person who wrote the code or made the change is also on the hook. So if I fail, we both fail. So sometimes that can mean I have to tell a person this looks weird, but I don't know why. So I'm going to come back to it tomorrow. I'm going to take a walk, whatever the thing is. I'm going to go eat some strawberries, whatever the thing is you need to get, back into the mindset. You need to do a better review. Sometimes you just have to do that. Yeah, so a good example of this that happened fairly recently is we had a PR on one of our projects, and I was reviewing it. It was a very boring PR, I think it was 40 or 50 PDFs that had to be looked at, and I almost approved it, and I was like, no, I gotta go look at all these PDFs, which was very tedious, but I found 3 that were just completely broken and didn't work. So I think that's a thoroughness thing where it's very easy to look at a structural change, like the structure of some code in a PR, and just be like, it kind of looks okay, let's go. But it does often pay to spend 2 to 5 minutes of doing tedious things. Sometimes is all it takes to find bugs. Another good example of something is testing database migrations locally, particularly if you have a way to set up large data tables locally, or restore anonymous backups from production or whatever. There are certain kinds of migrations that will lock a table in certain database systems. MySQL, for example, is good at this, but it's really easy. It's nice to be able to test that locally before you do it in production, because if you do it in production, you can take the whole system down for an unknown amount of time. But if you do it locally, you can be like, oh wait, this is written wrong. So those are just a couple of things. So I think we're always trying to balance how good a job we do with not waiting forever. We can't look at something forever. So we often have to make a decision in some time period. So that's, I think, the main point I was trying to make. That's all my slides. I will have these slides to share, and I will put some links at the end of that for some reference material you can look at for some of the terms of art I said. So thanks for coming to my Smart Talk. There's not actually anyone here to ask questions, so if you ask questions in the YouTube comments, I'll try to get to them and answer them. So thank you again for watching. And again, my name's Joel Meador. I work at a company called SmartLogic, and thanks for coming.